Hello everyone and welcome to episode 4 of the C++ Mastery course. Now, so far we've learned how to store data, we've learned how to represent true and false with booleans. Now it's time to actually do something with our data, and in this episode we are going to look at operators. They basically tell our variables what to do, and we can produce various different results with various different operators. So without further ado, let's get into it. Now on the screen, you will see I have a small little program here with two variables, a and b. A equals 17, b equals 5. Let me just zoom in a bit for you guys. Okay. And you will see I have listed the 5 most common operators over here. We have the plus operator, a plus b. I mean, this is obvious. We know it's going to be 22. A minus b is going to be 12. A times b, 85. Maybe that takes a bit of time. But a divided by b, we get 3. And this is because of integer division. Both of these are integers. So it throws away the remainder. It tries to divide into the 17 and throws away the remainder. Now with the percent, this indicates modulus, the modulus operator. And this is the remainder after you divide. So here you see we recover the 2 remainder. Now if we go back to the division operator, let's now say you want that remainder, well then you're not dealing with integers anymore, you're dealing with floating point numbers. So let's have a look at that. Here we go. Now if you look on the screen, we have int x equals 7 divided by 2. This is 3, not 3.5 because of integer division, remember? But if we save a double y equals to 7.0, remember this is a double literal in C++, and we divide that by 2, we will get 3.5. So this shows that at least one of the operands, when using this division operator, must be a double for the result to also be a double. Likewise, we could have done this and it would have resulted in the same thing, but this would not have. This would have done integer division, okay? Like over here, if you see, we have double z, 7 divided by 2, it's 3. It's still integer division because it could then convert from an integer to a double, which is probably not what you wanted. So remember, at least one of the operands on either side must be a double for it to convert to a double. Over here, you can see that we are casting the 7 to a double, which then, makes it a double. And therefore, one of the operands on either side is a double. And therefore, we get 3.5 and not just 3. Okay. Now, I want to go back to the modulo operator and show you some cool things that you can do with it and some interesting use cases, that might show up while you're programming. Well, if you need to check whether a number is even or odd, like let's say 17, we do is even number mod 2 equals 0. So the remainder is 0. If it perfectly divides by 2, obviously it's even, guys. That's mathematics, And if it's odd, then it does not perfectly divide by 2, aka there is a remainder of 1. Okay, so that is how you can check whether a number is even or odd. Over here, we will then print that out, true or false. I mean, we went through the logic, so we don't have to do that. Over here, you can make sure that a value wraps around in a range using modulo. So let's say the current hour is 14, but we're working with 12-hour time. So we cannot represent 14 as that's 24-hour time. We will then take our hour, mod by 12, and that will then convert to 2, which is true, in 12-hour format, 1400 hours is 2. So you could use it for that as well. And then finally, for array bounds, let's say if you want to keep things within bounds and you just want to keep wrapping it to the beginning, you can do that as well. Let's say we have index 7, but our array size is 5. So this is currently out of bounds. We mod index by array size, and this will give us 2, a value that is now in bounds, right? And we don't query a vector or array out of bounds and the program crashes. So that's just some interesting uses for mod. Now we will just quickly go over the difference between an expression and a statement in C++. An expression is something that produces a value, for example, 5 plus 3. This produces the value of 8. A times B produces the value of whatever A times B is. A greater than B produces a boolean of either true or false. That's what an expression is, whereas a statement performs an action. So in this case, this statement over here stores the result of this expression into x. This whole thing is the statement, and this is an expression, all right? And likewise over here, the statement is printing this expression to the console, okay? That's just the short little difference between them. Another operator that we go over is the assignment operator. Over here, we make a variable, an integer variable called score, and we assign it the value of 0, okay? Equals assigns the value on the right to the variable on the left. Makes sense, right? Just like maths, kind of, you know? Score equals 100, we reassign score to be 100. Score equals score plus 50. It reads the current value, adds 50 to it, and then stores that into score again as the result, okay? This is the assignment operator. Now you may notice that score equals score plus 50, like we had in the last example, is a little bit verbose to write. So C++ gives us compound operators. Here we have score is 100. We can say score plus equals 50. This is equivalent to score equals score plus 50, which is 150. And likewise, we have minus equals, multiply equals, divide equals, mod equals. This is a shorthand way of writing things, and it's generally the preferred practice over writing score equals score plus 50. It reads a bit easier, you know, a little bit less code. We then have the increment and decrement operators. As we can see, int lives equals 3. We can say lives plus plus. This adds 1 to lives and is equivalent to lives equals lives plus 1 or lives plus equals 1. Similarly, for the decrement, we can say lives minus minus. This is subtracting 1 from lives, same as lives equals lives minus 1 or lives minus equals 1. Now with that increment and decrement operators, there are two different kinds: prefix increment decrement and postfix increment decrement. Let's say we have a equals 5 and b equals 5. Prefix increments first and then uses the value. So over here, we will first increment a to 6 and then save 6 into x. So x will equal 6. For postfix, we use the value first and then increment. So here we'll first save y equals b, so y will equal 5, and then b will be incremented to 6. Okay. Now generally you want to prefer prefix over postfix because it increments the value in memory in place and does not make a copy first, then increments it and then saves that copy. So always prefer prefix over postfix unless you have a good reason not to, and you know what you're doing, you know, you're consciously thinking about why you're using postfix here and why it makes sense. Even for loop counters, like a for loop, for example, at the end, you will say plus plus I instead of I plus plus. It's just better practice. And here is another example using increment and decrement. These two are equivalent for these two lines, these statements, you know, they're equivalent, they do the same thing. Well, and this one as well, right? They're all plussing 1 to counter, but they differ when they're used inside expressions. So if a equals 5, here a plus plus, first it prints a, so it prints 5, then increments it to 6, and then prints 6 at the bottom over here. Whereas b over here, first it will increment to 6, then print that, which is 6, and then if we print it again, it's still 6. So yeah, this is just to hammer in that point, you know. Our next operator that we're going to look at is something called the ternary operator, and it's basically a shorthand way of writing if else. So let's say our age is 20, we save that into an integer. The long way of writing this into a string of status 1 is if age is greater than or equal to 18, we're an adult, otherwise we're a minor. Whereas with the ternary, you can write this in one line and make it very clear to read. Status 2 equals, the first is the conditional check, so age greater than or equal to 18. Then we have the ternary operator, which is this little question mark. Then it is what happens, what gets saved when the value is true, when this is true. So if this is true, we're an adult. We have our semicolon, 2 dots, and then what gets saved if it's false, which is a minor. Okay, that's the syntax. So first is the conditional check, ternary, value if true, semicolon, value if false. All right, and these two will print the exact same result. Now the ternary operator may be new to some people, so let's go over some more examples. Score is equal to 75. We save that as int. Lives is 1. Balance is minus 50. Now we check a pass or fail. Result. We check our conditional. If the score is greater than equal to 60, which it is, then ternary, value if true, pass, semicolon, value if false, fail. So in this case, it will pass, right? Scores greater than 75. Singular or plural, we check our conditional. If lives is equivalent to 1, which it is, we print life. Otherwise, if it's not, we print lives, but in this case, we're gonna print life. Okay, inline and output, balance is, and then if our balance is greater than 0, it's not, it's negative, we print positive. Otherwise, in this case, we print negative. Finding the larger of two numbers, we have a equals 42, b equals 17. Larger, we say if a is greater than b, then a is the larger number, otherwise b is the larger. And then we can print that. These are different ways that you can use this ternary operator. It makes reading stuff very nice, very easy. And yeah, you should definitely use them when you see a if-else scenario that's easy to read like this, okay? Now we will quickly go over the operator precedence, okay? So let's say we have an integer result, and this equals 2 plus 3 multiplied by 4. Just like maths, this is going to follow the BODMAS or PEMDAS rule. And the multiplication is going to happen before the addition. So it's 4, 8, 12, plus 2 is 14, not 20. 3 plus 2 times 4, okay? And there is a whole list of precedents, and this is the priority. First, we have the increment, decrement, postfix. Then it's the prefix. Then we have the logical not, the unary minus. You get the idea, right? This is the list. You don't have to know this off by heart. Basically, whenever you're dealing with something like this and it's confusing, just put it in brackets, okay? Don't let the reader have to memorize this, and don't make yourself memorize this. Just use brackets and make your code more readable. And that's it for today's episode. If you enjoyed the video, please like and subscribe. If you have any questions, feel free to comment them down below and I will answer every single one. Stay tuned for the next episode. I hope you guys are learning, and I'm hoping to teach you much more C++ concepts in the future. Thank you.